So we have some transportation problem in which we have been given the supply and the demand, and also the cost that it take from sending the material from, let's say, supplier A to market one, that would be 48 per uh, let's say per truck or per kg or something like that, and simply the rates for other such matrices are also given here. So uh, first of all, we have to check if we the question can be solved or not, and for that we have to check whether if it is balanced or unbalanced. So if we can see, the sum here is 50. Similarly, the sum here is also 50. So this is balanced. Let's say this would have been a bit lesser, 14, then the total would have been 49, but that would be the supply capability, but the demand was 50. So we don't have enough supply to fulfill this demand. Then would have been unbalanced, and the solution would have been infeasible when supply is less than demand. Even if it's unbalanced, let's say we have 50 supply, but our demand is 40 only. So in this case, it is unbalanced, but it's feasible because supply is greater than demand. And for solving these kind of questions, we have two models, model A and model B. So in model B, we use inequality, and in model A, we use the equal sign. But model A can only be used with the balanced question, whereas the model B can be used with unbalanced as well, and also the balanced one. So it is preferable to use the model B only. So in model B, the simple constraints are the let's say we are taking a variable xij, where it is the number or weight of material that will be transported from supplier I to market J. So sum of all these should be less than equal to the supply capability of that supplier. Similarly, another equation that could be made is from the market perspective. So here also it would be xij only. Here the I will remain constant and the j would vary from 1 to how many, let's say market there are 5. So and here j would remain constant and I will vary from 1 to 3. And here the sum should be greater than equal to the demand, because this much demand has to be fulfilled, so that is the bare minimum, whereas this much supply is the maximum that could be given. So that would be the maximum limit. Okay, so I will show you in some time how can these questions be solved using Excel. But first off, let's say we don't have Excel accessibility and we still need to solve it. So for that we have a northwest method. So in that we will get a basic feasible solution, but it won't be the optimal. So let me set it to the original value. So this is a balanced one. We have 50 on both sides, and let's solve it. So start from the leftmost corner. Here the market demand is 10 and the supply is more than that, so we can give it the whole 11. So that way this will get 0 and this will be reduced to 4. So the supplier still has some capability to fulfill some of the orders, but this market require has been completely fulfilled. So we will move off from this market to the next one. Here the demand is for 12, but this supplier A can provide for 4 only, so it will provide those 4. This will be reduced to 8, this will be completely used up, and now we move to supplier B. Now it has a demand of 8, but and the supplier can give 20, so we will provide those 8. This will be 0 and this will reduce to 12. Still, now moving to market 3, and supplier B has the ability to provide for 12. The demand is 9. We will provide these 12. So we will provide those 9 here. This will be used up. This will reduce to 3. Again, the demand is for 10. Moving to the next market. So here it can just supply the 3. So this will reduce to 7. This will be completely used. And now since the market demand is still there, but the supplier has used up all its capacity, so we'll move to a different supplier. Now here also we will take 7, and this will be used up. This will 8, and this will be completely used up. So if the question is a balanced one, in the end the whole supply capacity will be fulfilled for the demand. But let's say if it had been more, let's say 20 or something, so even after this, 5 more quantity of supply would have been remain unused, which would not have been because there was no demand in the market for that. Start with one of the most complex question that we have done for this transportation topic. After this, we have just two types of question: the work and task, and the cricket league one. So here also we have been given, like, from supplier A to market uh, supplier I to market J, the cost for various locations. And here we have been given these different demands, similarly the different supply. Now it's simple. Like all we have to do is we have to make a matrix, and we can put in any values, let's say 1 or something, and we just have to see if these demands are met, which was given to us. And similarly we have to make sure that the supply should also be fulfilled. So let's say I am replacing the data. Okay, so now these constraints were already there, and here we have already used the sum of the rows and the columns as per our requirement. And we have the objective function as well, which is the sum product multiplication of this box with this box. So now let's simply apply the formula. You have to open solver. Here we have already select the objective function that we want to. Then this box has been selected. Here the terms are different, but you can do it on your own even if you want to. Let me show that. Oh, the wrong box is selected. Let me select it once again. Yeah, so it's done. Similarly, these two constraints are also there. So as I have told you, the demand should be greater than and equal to, and the supply should be less than, because you can't breach that. So simply clicking on solve, we get this value. So similar, at this time we were not concerned with, let's say, the total rice that we were taking, what were the three grades for them. But if you try to solve it individually for each of these, and then you will try to add these up. So they will be greater than this one because um, with an additional constraint, as we have learned earlier as well, the minima will remain the same or will increase a bit. So here also, since we are putting in some additional constraints, so it is going to increase. Okay, so we have a work task problem here. So we have certain workers and we have certain number of tasks. So these are the cost that is going to incurred if a particular worker does a particular job. Similarly here also, and usually a worker can do one task only. So it we can keep it binary, or we can simply put in this constraints that it should the sum should be equal to 1 or here. But you if you observe closely, you will see that an inequality sign is being there. So this is because we have more number of workers and the task is one less. If let's say we even have a task 4 as well, then this inequality was not required, simply we have to use the equal sign. So here also, let's say I am distorting the value a bit. Okay, and so something like that. So now let's try to solve it using solver. Simply go to data. Here is the objective function, which is the sum product of this box with this box. Okay, now so we go to solver. This is our objective function. We need to minimize is because we want to pay the least. Then the decision variables are here, and now these are the constraints. So as you can see we have particularly used the inequality sign, and here we have the equality sign. So let's just solve it. So you can see we got a, and let's say we have a fourth task as well, task 4. So let's say we have some certain values 50, 85, 55 and 90 and 120. Okay, so here also we need to have a task 4. It can have any value, let's say 1. So this we have to move from K to L. Okay, so this one's done. Here also we need the sum of the new task and 1. So let's say now, and this one has to be modified as well. So this should be equal to sum product of this with this. And now let's try to solve it. So here it is still the same. This needs to be modified. Okay, constraint needs to be updated. So this one I don't think we have to do anything. Now let's solve it. Yeah, so even with one and okay, so one thing that I I did wrong was here we can change the inequality sign to 1. So now let's solve it. The value won't change, but uh, although here you can see the inequality only, but in the solver we have changed that sign, so that is there, and this work task is being solved. So let's move to the last question, that is the that IPL kind of match. Okay, so this in this each team is being provided a placeholder, and according to that only they are going to play the further matches, and the placeholder that they have, it has a particular price for that or penalty amount for that. So accordingly we can see the overall cost of the match of the whole league. So here also simply we have done the sum product of the cost along with the placeholders, and this is similar to that worker and task format, in which a single team can have a single placeholder only. So simply a equal to sign can do the work here, and simply using the solver. So here this constraint is the additional one, so we can remove that because that is the second case. So here I guess we will getting a lesser value like 196 because we have further relaxed the constraints. But talking about this question, the additional part, like when in the second round when the matches are happening in Mumbai, both the Mumbai teams can't play with each other. So for that simply if we took the sum of the placeholders which can't be both cannot happen simultaneously, so simply if we took the sum of them and if we keep it less than 1, so as it was given in the question I guess, um, if it's at second position and fifth position, so 2 versus 5 was a possibility in round 2. But so let's say here MSG was playing at second and MI was playing at fifth. So as you can see here, the amount already increased from 0 to 2. So this is uh, placed in such a way like the second position for MI plus the fifth position for MSG should be less than equal to 1. Similarly, the second position for MSG and fifth position for MI should be less than 1. And similarly, there were other situation also like third and sixth, fourth and 1. So for that total we can have 6 constraints. So these are here, these are the sum of the cells which should not have the sum greater than 1, and we just have the inequality and we have mentioned that it should be less than 1. So now this is the additional constraint, so we will just add it to our solver. So this should be less than equal to this. So now since we are adding an additional constraint, so even our minimized value would be more a bit increased. Okay, so now let's solve it. So we have 205, so this is the answer with this additional constraint.